Okay, I think we need one more video on this section to make sure it's good. 81x squared equals 4. So this one's a little bit different, and we still want to try to set this equal to 0 if we're trying to make use of the factoring. So let's go in the tutor mode, and we'll kind of go through the steps like they do. But what I can already see is going to happen is that with the 81x squared and the 4 that we're going to subtract on both sides, we're going to end up with what looks like the difference of two squares. So you remember back from section 6.2a, they gave you some different special types, and it's actually popped up, with the, they did one example in the previous video with the, I think it was a trinomial perfect square, and I said, well, you don't need to necessarily know the pattern, you could just do it the way we've been doing it. With this example, though, you really do need to kind of see the pattern because it's a different type. It's a binomial. It's a difference of squares. So they're saying if you subtract 4 from both sides, what do you got? I've already kind of talked through that, but we'll write it in. Okay, so 81x squared take away 4. And then they say, hey, do you notice that this fits the pattern of the difference of squares? They say, well, what is each piece based on that pattern? So I'm thinking about what was times itself here, or what is times itself right there. It looks like it would be 9x. What's times itself right here? 2. So if those are the pieces, 9x and 2, that you're going to have a plus minus binomial situation here where you have those values inserted. 9x plus 2, 9x minus 2. Prove it to yourself, multiply it out, first outside, inside, last, so you get all the combinations, you're going to get back the 81x squared minus 4. Okay, so if those are your factors, 9x plus 2, 9x minus 2, then we can go and solve each one out. I could talk through it pretty easily, but I'll show you the tutor mode again just to make sure you got it. That one of those factors has to be 0. So either 9x plus 2 equals 0, which sets up one case, or 9x minus 2 equals 0, which sets up the other case. So if that's true, you solve each little equation, basic linear problem solving, subtract 2 from both sides, divide both sides by 9. Those would be the steps you would need to do to identify negative 2/9 as a solution. This one here, add 2 to both sides, divide both sides by 9, and then I put positive 2/9. So those are your two solutions. Okay. Alright, here's another problem here. 7x squared plus 11x minus 3 equals 0. If we were to subtract 3 from both sides, we'd end up with 7x squared plus 11x minus 6 equals 0. If we use their method for factoring, from here we see that, well, we get a number out front that's a 7. I can multiply that with a negative 6 and get a negative 42, and I try to think of two numbers that multiply give me negative 42 but add up to 11. These numbers aren't too bad, but keep in mind that if it's negative 42, you're trying to think of a positive and a negative. So it sometimes makes a difference in terms of the process, because it's going to maybe take something that's not quite as close together, and we can still get that result. In other words, 42, not negative 1 times 42, not negative 2 times 24, but what about negative 3 times 14? Okay, you start testing, and those numbers actually work, don't they? Because if you have 14 and a negative 3, added together we'd get 11, but that would be the product we're looking for. Okay, again, you can test it with your calculator until you get the right combo. Alright, so if that's true, we've got the 14x and plus a minus 3x. Okay, and with those numbers, we can think of the first group of two, that they have a greatest common factor of just x. And if I divide the x away, I'm left with 7x minus 3 left from the inside of dividing away from those guys. The second pair has the greatest common factor of 2, and I should get a match, because if I divide by 2, I get 7x take away 3 again. So like I've said before, if it's going to work out, the combination you got, you kind of verified it, but it's verified again by getting a 7x minus 3 repeated. It has to work out that way if you found a number combination that worked to begin with. So 7x minus 3 is in one set of parentheses, x plus 2 is in the other set of parentheses. Okay, so those are our factors, x plus 2 times 7x minus 3. And if you solve each little one out, set each one equal to 0, I should say, and then solve each little one out, you would get a minus 2 for the first one. For the second one, you'd have to add 3 to both sides, divide both sides by 7. You'd end up with a fraction of 3 over 7. Okay, I'm glad I found this one, because this one's a little different. I don't know if you remember back when we did the beginning of Chapter 6, we talked about, that was when it really introduced the greatest common factor idea. And it's something that sometimes you go and you almost skip that step and you try to, do other stuff. But sometimes a problem like this really gets people, because this problem is all about the greatest common factor. It looks like some of the ones we've just been doing, but in reality, because there's no constant term, there's no third term on the left that's a constant, we can just say that these two terms have an x in common. We could pull that out. So that will be out front, and then 9x plus 2 is left on the inside. That's all you need to do. So it makes a huge difference here, based on the fact that there's no constant, that we can pull out the x that they have in common, and it is factored. That's the goal right there. Okay. So if that's true, so this is kind of a different case, right? It was pretty quick. But the steps are still the same, that if I set each factor equal to 0 and solve, I can get solutions. If I set x equals 0, x equals 0. There's nothing more to say about that part. The second part, 9x plus 2, I could subtract 2 from both sides, divide both sides by 9, I get negative 2 ninths for a solution on that one.